parameters. So if its probability density function is given by, so f of x is to mu comma sigma square. These are the parameters. These are the mean and the variance. So is written as the f of x is to mu sigma square is equals to 1 by root 2 pi into sigma. 2 pi into sigma exponential. Exponential, or else you can take e also. Exponential minus 1 by 2 x minus mu by sigma whole square. Sigma whole square. This is the f of x formula. F of x is to mu x square. So mu x square. So we can, I already told exponential can be written as x. So when this formula comes means, so if the x is having the minus infinity and infinity as the intervals, then or else mu has the minus infinity to the infinity, or else a sigma square is always greater than 0. So if these three conditions satisfies, then the value of f of x is to mu comma sigma square is this. Or else if this any of the one or any two or three are not satisfying, then we can say the f of x, we can say f of x is to this one equals to 0 if these three conditions are not satisfying. So we know there are the two main conditions for anything, for any distribution, that is integration minus infinity to the infinity f of x into dx is equals to some equals to greater than or equals to 0. It should be greater than or equals to 0. This is the first condition we need to understand. Next, the second condition is, I'm sorry. So the first condition is f of x should be greater or equals to 0. This is the first condition. And second condition is integration minus infinity to the infinity. F of x into dx should be, if we integrate this f of x in f of x, then we should get equals to unity. It means 1. So these are the two conditions we need to memorize. Next. So, we know this is the formula. So, let us use the transformations, like we can convert it into very easy. So, we are taking, so this part, x minus mu by sigma as z. We are taking it as z. So, what happens if this mu as well as sigma goes there? This is x is equals to sigma z plus mu. So, what happens if we differentiate? So, dx is equals to uv. We are doing uv. Then sigma into dx will be, and mu will be 0, equals to 0. So, from this, we are getting integration minus infinity to infinity f of x into dx equals to 1 by root 2 pi sigma integration minus infinity to infinity e power minus 1 by 2 z square into sigma dz. So in this sigma dz, and we can convert this, we are taking this sigma and sigma cancel. So it will be like this. So what happens next means, if you convert the z square by 2 equals to t, then the t will become z square is equals to 2t. Then what happens if we differentiate? So 2 will come before, 2z into dz is equals to 2 dt. So this is the differentiation we are doing. This is a differentiation. So you will get like this. So dz equals to dt by z, and it can be written as dt by root 2 x, because z is equals to root 2 t. So after that, what we are doing, we are integrating it. So minus sigma, minus infinity to the infinity, f of x into dx equals to 1 by 2 root 2 pi integration minus infinity to infinity 1 by root 2 into 1 by root t into dt. So this is the things after we are substituting the all the things. So what happens next means, so we are taking this outside. See, so this will become like 1 by root 2 only. Then we are taking the minus infinity to the 0. Then it will become a 2 infinity. Then e power minus t 1 by root 2 into 1 by root t into dt. Again, after root 2 and this 2 can be cancelled. So it will become 1 by root 2. Root 2 is cancelled, right? This 2 and this 2 is cancelled. So we can say, so 1 by root pi into integration 0 to infinity t power minus t into t power 1 by 2 minus 1 into dt. So after that, this can be written as r into 1 by 2. So 1 by r by 2 equals to root pi. So from that, we can conclude that this pi can get cancelled and minus infinity to the infinity f of x into dx is equals to 1. This is like proving it. Like we are saying the two conditions, right? What are the conditions? F of x should be or must and should be greater than or equals to 0. This is the first condition we can conclude it. Second condition we are proving it. For the first one, like all the distributions will do the same process but a little calculation differences. So second one also integration minus infinity to the infinity f of x into dx is equals to 1. This is the process we are proving. So this will be the same but different calculations will be you need to do for all. So we'll find out the mode of the normal distribution now. So mode is the value of x for which f of x is maximum. So that is mode of the solution of f dash of x and f dash of x is equals to 0 and f double dash is also equals to 0. Double dash means we are doing the differentiation twice. F of x, f dash x means we are doing the differentiation for the first time and for the second time we are doing f double dash. So this is the formula we have. This is the normal distribution formula have. To get the mode value, take log on the both sides and differentiate with respect to and equates to 0. They are saying if you want the so if you want to simply fix it, then it 1 1 we can see a error like 1 second. I'll rectify it. So here we are taking the f of f dash of x is equals to 0 and the f double dash of x should less than 0, not equals to 0. There is a mistake. You please correct it. So f double dash of x, is less than 0. It should be less than 0. So for simple like calculations, we'll apply the log on both sides. For this equation only, we'll apply the log. Then after applying the log, so this is log a into b. So if it is in the If the log a into b, we can write it as log a plus log b. And if you have the log a divided by b, then you can do it as log a minus log b also. So we are having the log a into b, then it can be written as different log a plus log b. So we are writing it as log a plus log b. So next one, the first one also. If we see the first one, I can show you. Uh, so this is the first one. So already told log a. If we are having a log a by b, then it can be written as log a minus log b, right? So in the next step also we are doing that only. See here. So log a minus log b, and again minus 1 by 2 sigma x minus mu square. So log 1, it's always 0, we can 0, so minus log into same thing we'll write here only. We are getting log 1 is equals to 0 here. So after getting that, we'll differentiate with respect to x and equating it to the 0. We'll equate it we equating to the 0, and we'll differentiate with respect to x here. So if you are differentiating d by dx, dou by dou x, you can say anything. So log f of x is equals to dou by dou x of minus log into root 2 pi into sigma, and minus 1 by 2 sigma square. For this also we are doing again dou by dou x, x minus mu whole square. So, if we are doing this, this is a formula like for this f of x, it will like we'll get f of x into f dash of x. So for this, we are doing the differentiation again. This is the term log. So log x can be written as 1 by x actually. So for the x also, we will do the differentiation again. That's why we are getting x dash. So 1 by f of x into f dash of x we are getting. For this also, for this whole term, we'll get the 0 value, and for this term, we are doing the differentiation. So for dou by dou x into x minus mu square, so the square will come upside, x power n, right? So n power x we can say. So into again for this differentiation, x differentiation, we can say it as 1. So again 2 can be cancelled, 1 by sigma square mu x minus mu is the answer. So this is the thing. So we are having the 1 by f of x into f dash of x, right? So f of x can be sent that side, right hand side. So we will get the answer as f dash of x is equals to 1 by sigma square x minus mu f of x. So what we are saying, f dash of x is equals to 0, right? In the conditions, and it should be, the sigma square should be greater than 0. So this should be greater than 0 only. And f of x, this should be also greater than 0. Greater than or equals to 0. So what is the remaining term we are having? Only x minus mu we are having. So it may be equals to 0, right? So we'll consider only x minus mu value. So if you are taking x minus mu value equals to 0, because the condition is sigma square is always greater than 0 and f of x is also greater than or equals to 0. So only term we are having is x minus mu. We'll consider it as 0. So we'll get x is equals to mu. X is equals to mu. This is the thing. So next, this is the f of x value. So from the f of x, we got x is equals to mu. Then coming to the f dash of x, f double dash of x, we are getting dou by differentiation. For this only we are differentiating twice, second time. So it will be for this only we'll do d by dx, dou by dou x of 1 minus 1 by sigma square x minus mu into f of x. For this we'll do 1 minus 1 by u into v we'll do. Then this is a formula. So it will become minus 1 by sigma square into first f of x into this one again 1 it will become, and mu of x minus mu into, for this differentiation we'll take it as f dash of x. For this differentiation f dash of x. So you know u plus v is equals to the formula. So directly we are substituting here. So after that, what we are doing means, for this f dash of x, what is the value again? F dash of x value is this. So we'll substitute the f dash of value here. So we'll get what we'll get into, right? So 1 by sigma square will be same, f of x will be same. So this can be common, like this term is same in both terms. So we'll take minus 1 by sigma square f of x as a common. So this term becomes the 1 minus x minus mu whole square by sigma whole square. This is the value we'll get. So what we are doing means, in the f of f dash of x, we got x is equals to mu, right? So we'll substitute the x is equals to mu here in the second one, this one. So if we substitute it, it will become the 1 f of x into 1. This will become the 0, right? X minus x 0. So we'll get, lastly we'll get minus 1 by sigma square f of x, where x is equals to mu we are taking. So after, what is the f of x value? In the previous, we have already know what is f of x value. F of x value is this. We are substituting the f of x value here. Minus 1 by sigma square into 1 by root 2 pi sigma e power or exponential power minus 1 by 2 x minus mu by sigma whole square, where x is equals to mu. This is the derivation. So this is the thing we got from this. So it is less than 0. So in the first one, they told f of double dash of x is equals is less than 0, right? So we concluded that it is less than 0 only if x is equals to, we are taking as mu. This is a mode also we can consider, the normal distribution mode as x is equals to mu. So median of the, this is a mode, right? We'll now do the median of the distribution. So everything will be same, a little bit confusion they'll give. So same, if x follows the random variable, x follows the normal distribution, mean and variance mu and sigma square. If mu is having the minus infinity to infinity value and sigma square is greater than 0, then the probability distribution function means the PDF of the normal distribution is given as this formula we know in the previous only. So for the normal distribution, mean or else we can call it as E of expectation of x or mu, anything is same, the mean we are doing. So this is the mean, and the m is the median of the normal distribution. The total class can be divided into two parts. So the two parts, like in the normal also we'll do median as we are taking dividing the whole one into two parts, and we'll doing something. So here also we'll do as taking as two parts. Now we'll consider this one, integration minus infinity to infinity f of x dx is equals to 1. Integration minus infinity to m f of x into dx plus simple two different terms we are doing. So minus infinity to m, we are taking minus infinity to m, and we are taking m to minus infinity. So these are the two things we are dividing actually. So equals to 1. So f of x, we know we'll substitute the f of x value here also. After substituting the f of x value, we'll consider it as 1 by 2. This will come this side. So now consider the integral parts, like minus infinity to infinity, right? So this one we are considering the infinity. Again, this part we'll consider it as 2. Minus infinity to m, right? Minus infinity to mu 1 1 and mu to m. Two different intervals we'll take. So first, taking the first integral, we can conclude that 1 by root 2 sigma pi, that is integration minus infinity to mu e power minus 1 by 2 x minus mu by sigma whole square into dx. So we'll consider this as x same z. So from that we'll conclude these points actually. Taking the limits, and we are doing same process we are doing in the previous one also. So if you do a correctly one distribution, then it is very easy for you to do other distributions also. So make sure that you don't miss any single calculations or any differentiations or any integrations. So we know this is integration of minus infinity to infinity e power minus 1 by 2 sigma x z squared into dz is equals to root 2 pi. So root 2 pi. So what happens, minus infinity to infinity, right? They'll take as 0, then it will be the 2. So the 2 will come this side. So root 2 pi by 2. So in the substitution in this equation we'll substitute this, and we'll go in the final one we'll get mu is equals to m is equals to median. So here the mean and median will be same. So what we are getting as a mean in the normal distribution, we are getting mean as a mu or expectation of x or mean is equals to mu. In the median also we are getting the mu only after doing all these calculations. So we can conclude that the normal distribution mean is equals to mode, and mode is mean is equals to median, as well as mode is equals to x is equals to mu. For symmetric one, the normal distribution is symmetrical since mean and median and mode coincide in the normal distribution. For the symmetrical one, we can see mean is equals to mode is equals to median. This is the conditions for the symmetric one if the normal distribution is symmetrical. So now coming to the MGF. MGF means movement generating functions of the normal distribution. When coming to this, we can say similar thing. The random variable x is following the normal distribution with the mean mu as well as a variance sigma square. These are two parameters we are using. Then the MGF, movement generating function of the x, can be written as m of mxt is equals to integration minus infinity to infinity e power tx f of x into dx, where this f of x is a PDF of the normal distribution. We already across know across this all the f of x from the normal distributions. So we are substituting the f of x here. Then again we'll do the transformation, like we'll consider this and we'll equate to some other number value. So from that we can do the differentiation and everything. So we are equating x minus mu by sigma is equals to z. So sigma comes this side, x minus mu is equals to sigma z, and we are doing the differentiation, then it will become dx is equals to sigma dz. So for this value I'm substituting this value in here. So after substituting this value for easy calculations, one second, see, for the easy calculations I am doing like this. So in the place of dx I am substituting sigma dz. This sigma can be cancelled, then it becomes 1 by 2 root 2 pi minus infinity to infinity e power minus 1 by 2 z square. If we consider this as a minus 1 by 2, this one minus infinity, like I'm taking the common, this is e and e only, right? We are having the e and e, so we can take the common, we can add it actually. So minus 1 by 2 z square, as well as c into rho into mu into t, I'm sorry. So T into mu as well as T into sigma z. So this one we are like adding. So exponential power x into exponential y can become as exponential x plus y. So this is a condition. So after doing this, we are like taking this out. From here, we are taking this out, e power mu t. We are taking this out. So it will become a similar one. Then again, we are taking this also out. So after doing that, the sigma as well as this also by doing the square. So in the last, if you do all these conditions, once again, So here we are taking z minus mu t is equals to m. So will becomes the dm, and integration of minus infinity to the infinity e power 1 by 2 minus 1 by 2 x d x square into d can be becomes as root 2 pi. It can becoming as root 2 pi. So now from this dm can be written as dx dm, again this one can be written as root 2 pi, this can be written as root 2 pi, we are doing it as root 2 pi. So therefore the mx of t is equals to e power mu t plus 1 by 2 sigma square t square, because this root 2 pi, this root 2 pi can be cancelled. So I hope you are understanding the points, everything. One second. So this is the required NGF moment generating function for the normal distribution. In the star equation, if we with respect to, we are differentiating with respect to 2 and we keeping t is equals to the 0, then it will be like this. So after mu 1 1, we are doing the moments mu 1 1. So in the place, if we are taking the 0, then it will becomes 2, 2 can be cancelled, and this is the value. So this is the normal mu 1, 1, right? So if we keep the t is equals to 0, then it is mu. So the mean will be equals to mu. In the normal distribution, the mean is equals to mu. Next, coming to this, so we are equating double differentiation. We are doing for double differentiation. This is the second one. So first one we are differentiating, and second one we are differentiating for the variance. So this is the mean, we are getting the mu, and the variance for the normal distribution we are getting as sigma square. So actually we are generating the moments, right? For the first one we are getting this, and for the second one, the mu 2 1, for second moment generating, we got like mu 2 plus sigma square. So what is this mu 2? Mu square. So in mu square is nothing but variance. So we are doing the variance, and we are getting the mu sigma square as the variance. So from this we can conclude that mean is equals to mu and variance is equals to sigma square. Then we'll see the additive property for the normal distribution also. Statement we'll see first. Sum of two independent random variables also follows the normal distribution. Like they are saying, two normal independent random variables can also follow the normal distribution. So if you are taking uh, the random variable x and it is following the normal distribution mu 1 and sigma 1 2 square, sigma 1 square. So the next one will becomes y follows. We are taking one variable is x and second variable we are taking as y. So and it is following the normal distribution mu 2 and sigma 2 square. Okay. Mu 2 y, we are taking y as mu 2 and sigma 2 square. So two different things we are taking actually. So this is also following the normal distribution. So if we sum like x and y, two random variables, will get it is following the normal distributions. So this will become mu 1 and mu 2 plus mu 1 and mu 2 and sigma 1 square plus sigma 2 square. This is the addition of x1 x plus y. So for the solution, we are taking f of x value of the normal distribution. First is moment generating functions of the normal distribution we already got in the previous section. So that is mx of t is equals to e power mu t plus half sigma square t square. So this is they are saying this is also follows the normal distribution by taking the x follows the normal distribution mu1 and sigma 1 square, and they are saying y the other random variable is also following the normal distribution mu2 sigma 2 square. So these are the values. Then summing up these two will get what we are getting. Just let me zoom in. So what we are getting here. So moment generating functions of x and y of t is equals to mu1 and mu2 will definitely add it. Mu1 and mu2. Then this one also can be added. 1 by sigma 1 square plus 1 sigma 2 square t square. So this is adding the both x and y variables we are adding. So this is a form of moment generating function for the normal variate. This is the sum of the two independent variables also following. So what happens? The x is following the normal distribution, the y is following the normal distribution. The sum of the independent like x and y is also following the normal distribution. This is we are concluding from the statement. So coming to the next statement. Once again, coming to the next statement. So show the difference of the two independent variables also follows the normal distribution. They are saying what is the difference? We are summing up, right? What happens like if we sum x and y, we are getting it is also following the normal distribution. Now they are taking like take the difference. So first one will take difference like x follows the normal distribution, y follows the normal distributions, x, y minus this one, x minus y also will take. So this is the norm f of x. And for the same one, previous one will take m of x for the first x1 and y1 also will take. These are the two independent variables. So y follows y x minus y. Then we'll get this value. So what is that value? M x minus y of t is equals to, we got e power of mu1 plus mu2, right? We'll get mu1 minus mu2 into t plus 1 by 2 sigma 1 square plus sigma 2 square whole t square. So this is we will get from the x minus y if we are doing the difference. So from this we can conclude that this is a form of the moment generating functions for a normal variate, as well as the difference between the two random variables also follows the normal distributions. So what happens? The x, the y, if we are adding or else we are subtracting, if the x and y are not following the normal distribution, if you are adding or subtracting, it also follows the normal distribution. We can conclude this. So this is the example you can do. If you have any doubt in the example, you can ask me. So in the brief, I'll explain you what is the example actually. Two independent variables, x and y, they're taking x and y, and both follows the normal distribution, and mean is 1 and it means 1 and 2 and standard deviation 3 means what 1 and 2 and standard deviations 3 and 4 respectively. So z is equals to x minus y. So they are doing the difference minus. So write the density function of the z. So this is following, x is following, y is following, z what happens, we'll mix these two, we'll subtract these two, then we'll take the PDF of the normal distribution and we'll substitute it. It is very easy. Next, coming to the characteristics functions, normal distribution. What happens, we'll see now here. So f of x so like fx random variable is following the normal distribution with the mean and variance as the parameters. Then characteristics functions of the x is defined as, one second, my screen is Okay. So we'll do, so the characteristics of characteristics functions of the normal distribution can be written as phi x of t equals to integration minus infinity to the infinity e power itx into f of x into dx. So here f of x will be the PDF probability density function of the normal distribution only. In the place of f of x, we'll substitute the probability distribution function of normal distribution. Again, we'll do the transformations. Why we will do transformations everywhere means it makes us very easy to do the differentiation or anything. So we'll transform this f x minus mu by sigma as x, then x minus mu is equals to sigma x and dx is equals to sigma dx. So from this, we are substituting the d of x is equals to sigma into dx. So sigma sigma can be cancelled, and we are taking e power like e power a into e power b as e power a plus b. And then we are adding what we are doing means we are doing this all these things, and here we are substituting x minus like minus z, let it be sigma is equals to m, and dz is equals to differentiation of this can be as dm. So it can be written as same 1 by root 2 pi e power it mu minus 1 by 2 in the place, we can take directly a t square sigma square by 2 integration minus infinity to infinity minus 1 by this all thing means minus z minus it mu is equal same we are taking. This all things will be 0 and dx is equals dz is equals to dm. So in the place of this, we will conclude directly m. So we're getting the m value, right? So this is the thing we are doing. So from this, we'll dm is what we already know in the previous sessions, like dm is equals to root 2 pi. Root 2 pi can be cancelled. So we'll get the final answer as e power mu ti minus 1 by 2 sigma square t square. This is the cumulative characteristics function for the normal distribution. Next, coming to the cumulant generating functions of the normal distributions. So the cumulate generating functions, we can call it as a CGF of the normal distribution. So we are taking the log values and we are doing this. Actually, it can be written as, so k x of t is equals to log e mx of t. For this same mx of t, we'll apply the log value and we'll get the cumulant generating functions. So, so we are applying the long value to the m of first thing. What we are doing means this is a mx of t moment generating functions. So for this we are applying the k log value. Then it becomes, so for this we are log e can be cancelled. Log and e can be cancelled. So we get mu t plus 1 by 2 sigma square by t square. So mean is equals to k1 and this is the variant, right? Coefficient of this one, right? So mu is equals to mean is equals to mu, variance is equals to sigma square. It is a coefficient, right? So and the kr coefficient is like we are taking k x of t is equals to 0 and r values are 3, 4, so on we are taking. So for this, if you are taking r is equals to 3, then we will get mu3 is equals to k3 equals to 0. Then mu4 value will get it as 3 sigma power 4. So if you are doing the mitosis and the kurtosis, these are the values we'll get. So mitosis beta 1 is equals to 0 as well as kurtosis beta 2 is equals to 3. So we already know the formulas. Actually beta 1 is equals to mu 3 square by mu 2 cube, and beta 2 like kurtosis formula is mu 4 by mu2 square. So these are the values. If you do the moment generating functions like mu4, mu3, mu2, then we can get this all these values. Next, coming to the central movement for the of the normal distribution. So what they are saying here, the x follows the normal distributions with the parameters mu and sigma square, and mu will be having the intervals of minus infinity to the infinity, and sigma square is greater than 0. So this is a thing we are used for the central movements. So mu r is equals to expectation of x minus expectation of x whole power r. So in this place of r, we can take any values, 0 to infinity values we can take. So like this, only for this value we are taking 0 to 1. So what is the conditions means, if you are having the r is equals to r value, we'll have the 2n plus 1. And if you are having the r is equals to t1 value, we'll get a 2n. We'll get the 2n. So we will take the two cases and we'll describe. So we are taking the odd one first. R is equals to 2n plus 1. So in this place, we are taking like r value as a 2n plus 1. Same f of x value. Then we are doing. We'll see what. So we are taking the. So we are taking the odd one, r is equals to odd value, and we are doing it. So again, we are using the transformation x minus mu by sigma is equals to z. So from this, we can say dx is equals to dou x is equals to sigma into dou z. So we are substituting the of x value, and we are getting the mu 2n plus 1 value as 1 by root 2 pi into sigma 2n plus 1 into 0. So this will becomes the 0. For the values, if you are taking the n is equals to 0, 1 or 2, you'll get 1 at 2, 3. And mu1, mu3, mu4, all the values are 0 only. So it concluded that if you take the odd numbers, will have the definitely 0. And the second one, we already did for the rectangular distribution. For the same process, we'll do the transformation again. We'll get something. For that, we'll differentiate. See, for this value, we are differentiating. This can be written as 2 into 2. This for this integration we are taking the 2 power n outside. So by replacing the n minus 1, we are getting this like this equation and this equations we are dividing and we are getting this action. So this is the final output we'll get. That is mu 2n for the even numbers. It will become 2 sigma square n minus 1 by 2 mu 2n minus 2. This is a value for the even numbers if n is equals to 0, 1, 2, 3 in. So this is a mean derivation from the mean for the normal distribution. So this is the derivation thing we need to check it once. So mean derivation about the mean is this integration minus infinity to infinity mod x minus mu f of x into dx. For this, f of x will be same PDF function of the normal distribution. We'll substitute it, and from that we can conclude that like we will take this outside, so it will become outside. Again, we'll do the transformations and we'll get the value as this. So again, for this value, we'll take this event. I'll show you it. So mod z e power z square by 2. They are taking minus 1 by 2 z square, or z square by 2 is same. So we'll take and we'll do. So mod z is equals to z, right? So what happens? Z square by 2 is equals to t, because minus z square by 2, or it is having the moderate, z square by 2 is equals to 3. So z square by 2, from this we'll convert this side. So d of differentiation we'll do. From the differentiation we know dx is equals to dt value is this. So from this value we'll conclude this. So this is a value we'll get from the previous one. If you're all like clear about the previous one, you'll get to know this also. So from this, so root 2 by 2 by pi into sigma e power minus t by minus t, sigma infinity to 0, 0 to infinity is the point. So we'll apply the like intervals here. So minus 0 to the plus 1. So it will become plus 1 only. So it will become root 2 by pi into sigma. So we know as approximate value. So the approximate value of this is, so root over 14 by 22. Why we are taking 14 by 22? So root 2 by pi value. What is a pi value? 22 by 7, right? 22 by 7 into sigma. So this 7 comes upside. So it will become 14 by 22 into pi. If we do this calculation, approximately we'll get a 4 by 5 value. 4 by 5 value we'll get. So this is the approximate value, 4 by 5 sigma. So this is the thing we are getting the center. So what we have covered here, we'll once a glance, we'll have a glance. So we covered the mean derivation from the mean for the normal distribution, and we covered all the things like central movements, cumulant generating functions, characteristics functions, as well as statements we already did. So additive properties, like what are the additive properties? Like we are doing plus two variables and we are doing x plus y and x minus y. We already did the moment generating functions for the normal distribution functions, and we also completed the median as well as the mode. So what we are getting as a mode is equals to x is equals to mu, and mean and median we are getting mu. Same. These are the same things we are getting. So this is a class today. So again tomorrow in the next class we'll complete the normal distributions remaining part, and we'll start new distributions. If you have any doubts, you can ask in the comment section. Thank you.